Okay, I think I'm sharing my screen. Can you see this? Can anybody see this? Okay,
Yes.
excellent. So let's talk a little bit about intelligent agents. Like I said last time, it was Arthur C. Clarke who said that any sufficiently advanced technology is indistinguishable from magic. And also, if you think about AI, this is especially a field that may feel like that this is like magic, that it is doing so kind of complex things for the data that it is difficult to understand that computer can do this, and therefore it's easy to kind of it looks like a magic. And even if you are explained that this is using deep neural networks or support vector regression, if you haven't studied these methods, it doesn't help. It still feels like magic. And that was also one reason why I studied, when I studied in Tampere University of Technology, I studied digital signal processing and image processing. And those image processing algorithms, some of them were also like magic. And that was that gained my attention. That this is something, if people can do this with computer, I want to learn how to do this. And it also was seemingly magic what they did for the images. But then I understood how it works, and I was kind of slightly disappointed that this is just a simple mechanism. It is not intelligent at all. It's not magic. And in this course, many of these tricks that these AI magicians are doing are kind of revealed. So maybe you are also after this course disappointed that, okay, this was just a simple kind of automation. It wasn't magic after all, or it wasn't that intelligent maybe. But still, these are quite remarkable what these AI algorithms have currently achieved. So it's interesting to learn them and apply them in your own areas, and there's plenty of new businesses started based on this. And it's also helping people to mitigate climate change and do medical diagnosis, as we will see. And this one kind of interesting abstraction for AI is this intelligent agent, that we think that there is a world, the real world of information, and information and objects and processes which interact with each other. And then we have some agent which is monitoring what is happening on the world. It can have cameras so that it can have visual inspection where the objects are moving. It can have microphones so it can measure what kind of sound is coming. It can have lidars so that it can have information about distances, that where those objects are located, or it can have a spectral imaging so to understand the surface chemistry almost, and also these processes can be something like data in the network, like stock courses that the agent is monitoring, or industrial processes, or whatever. And then it has some kind of intelligence, and it uses this information. It uses perhaps also other information that it has stored as a state of the agent. And based on this information, it makes decisions, and decisions lead to actions. And these actions are something that it interacts or changes the world. For example, our automated car measures where it is going, where the others are going, and then it makes actions. It can brake or steer the car somewhere.
I think there is some noises. Somebody, I think, keep the mic on, and we have some noises.
Mm-hmm. Yeah, I can kind of. Yeah, now it's maybe all the mics are muted. Yes. Yeah, it's difficult to.
Yeah, great. Thank you.
Yeah, good. Then these agents can be in kind of different level of intelligence or different level of capabilities. But usually what they aim is to make rational decisions. That was one of our definitions of intelligence, that capability of doing rational decisions. And usually, or to agent to be intelligent, it's doing rational decisions. It tries to maximize its performance, measure it out by certain functions, and tries to tries to maximize its performance based on the information from the world and based on its own state and understanding how the world works. And yeah, so what do you think? I just showed you an intelligent agent that is measuring something from the world, and then it is interacting with the world. But can this kind of intelligent agent, are these all necessary? What if we don't have at all this perception in the agent, so it cannot measure anything from the world, or it does not interact with the world? Is there any possibilities that this kind of agent could be still useful? Recording, and we can take one step back. Or actually, we take one step forward. No. Yes. So the agent, so it needs perceptions, and it needs to make some actions. And to make perceptions, you need to have sensors that can be like cameras, temperature sensors, lidars, radars, or just or voltage meters, current meters, or just like reading some digital data flow. So sensor is something that is observing some information on the world and creating perceptions. And perceptions are like these observations in digital form. So it can be that voltage was 3 volts, or this is the image that I got, or the distance to the next car was 200 meters. So these are the observations that are measured by sensors. And then when the agent makes decisions, it decides, for example, to brake, and it makes actions that are affecting to the world. And to make some effect to the world, it needs some device for it. For braking, it needs a braking system. For starting an electrical motor, it needs to have a kind of switch that it can switch it on. Or if it needs more temperature in the room, it needs to switch the temperature, the heating system on. So these switches and valves and other systems which are actually affecting the world, these are called actuators. So we have sensors to get perceptions, and then actuators to interact with the world. This,
Thank you.
Yeah, you're welcome. So, and then there can be several rational agents, and each of them tries to maximize their performance. So, are they different, or are they the same? And any opinions on this? So they can be different, even though both are rational. They both try to optimize the same function, because they can have different information and they can have different algorithms. Some algorithms are better in maximizing their performance or they have better sensor information, or they have better state information, and therefore, or better possibilities for interacting with the world. So they can still be different, even they are kind of all tried to optimize their performance based on the perceptions and information that they have. And we divide these agents in several different categories according to the level or sophistication level that they have. Simple reflex agents, model-based agents, call-based agents, and utility-based agents. And if you look first about the simple reflex agent, it's something that is often called as a reactive system. So it has some perceptions, and it creates simple actions based on their perceptions. And they hardly have any kind of internal state or anything. So they just measure something, and if they know something important, then they react. For example, a light switching system, if it is dark and movement is observed, then switch light on, otherwise switch light off. So light is switched on if it is dark outside and movement sensor has observed some movement. If neither one is not true, then we go to the otherwise branch and switch the light off. And this can be could be implemented. For example, here is the semantic about it. So it has just the perceptions and some rules, and it reacts to these perceptions and makes some actions. And this particular function could be implemented in a simple code. For example, like this. I just show a little bit of Python code also, so that you get used to it, but you don't need to really go through this very deeply. So for example, here, this kind of agent can be that a program is called as infinite loop. So this block here belongs in the loop that is repeated while condition is true. And this condition that is literal true, it's always true. So this will always loop. So it will execute all these actions that I mentioned here, and then it goes back to the beginning and executes them again and does this forever. And what it does, it measures what is the amount of sunlight, it measures what is the amount of, is there any movement detected? So this is the perception loop. Then it goes decision making, checks that if the light is below certain threshold and movement is true, then we should switch the light on. Otherwise, we should switch the light off. And then there is action part. So based on these decisions, we make some actions. So we switch the light on. So we send a signal to the actuator that is in this case a switch that switches the light on, and then it works. Does it sound simple? And this is at the same time, this is an actual Python program that can be run. But I just had to interrupt it because it would run forever. So that is not very difficult or not very intelligent yet. So then we can have a little bit more complex agents that also have some model of the world. So in addition to having only observations and actions, it also knows a little bit how the world works. For example, we can it can have some sensors so that it can measure what is the distance to the cars in front of it, and it has some sensors, for example, GPS or some other sensors to know its own speed. So it can perceive the traffic situation and speed. And then it has some simple, in this case, very simple physical models. For example, it knows that if the distance to the car in front is delta S, and the speed difference of that car and our car is some amount, it takes this much time that the collision happens. And so therefore it can kind of understand that even though the situation is not critical yet, it will become soon, so we need to do some actions to prevent it. And then it has to be some actuators like braking system so that it can apply brakes so that its speed can be reduced. And this to find out how much braking has to be applied, it needs to understand a little bit like Newton mechanics. For example, F1 m times a. The force needed to braking is equal to the mass of the car multiplied by the acceleration. And then from this equation, if you know the mass of the car and we have some need for deceleration to prevent the collision, we can calculate how much force is needed, and then it can apply it. So this is already sounds slightly more intelligent than switching on light. And this is how it looks like. So it is exactly the same than the previous one. World, there's perceptions, rules, agent, and actions. But in addition to that, it has the previous one had also the state, but now it has some model. And now it was based on some Newton mechanics to understand the world better. So it can be a little bit more, it can make a little bit more complex decisions than this reflex agent. And here it is again as a code. So it's rather similar than the previous one. There are perceptions. It finds an obstacle. For example, it finds that there is an obstacle on the road at a certain distance. It can measure the distance to it using some function. And if it finds that there is an obstacle and delta s was the distance to that obstacle, yes. If that is less than 100 meters, for example, in this case, then it needs to reduce the speed or then it calculates how much time is needed before the collision happens, and then it calculates what is needed acceleration and what is the needed force. And if there is no obstacle, then force and acceleration are 0, and then it applies sufficient amount of braking power to stop the car before the collision. And now it has a state as well, so it knows its own acceleration and velocity. So, and that is needed for steering the car properly. Sorry, I closed the window. Just to show that that what kind of how that code would look like for this kind of model-based agents. Any questions? But it's enough to understand in this level that it has, in addition to the previous one, it has also the model. And then we can take a look at a little bit more sophisticated agent, that is the goal-based agent. So it's not, so this, the previous one, the model-based agent, was able to react to situations in more optimal way because it had a model. But this has also, in addition to model, it has some understanding also the consequences of actions. And because it also understands the consequences of actions, it can plan which actions are most appropriate. That what if I do this action, what will happen? Okay, this is not good. So I will try to different actions and do this. And then it can already kind of simulate different actions before doing anything. And therefore, it can reach the goal more efficient. for example, this can be an autonomous taxi or something, and it can or autonomous vehicle that tries to navigate to the certain location, and it needs to have a model for navigation, a map in this case, and then it needs to have sensors like GPS, so it knows where it is currently located, and it needs to know the goal, where it is going. And then it can kind of search from the map that which route leads to this target. So it can try different parts and turn right, turn left, turn right, turn left. I couldn't find this location. Okay, now I found it. Then it has a sequence of turns how to reach the goal. So goal-based agents can already plan its actions, and therefore it is the first one that you could actually think is that there is a little bit of intelligence in it. And this is so now these previous one were simple automation systems. It was really easy to show a kind of simple code for it, but here it is not that simple anymore. And the most of the code would be maybe in this consequences of actions part. So and it's different in all agents. So I cannot kind of present a general model about this any longer because it's more complicated than that. And then we also introduce one more concept here, that is utility. And utility is fitness for a purpose. So this kind of agent is similar than the previous one. It knows the consequences of actions, but it can also measure the utility of actions. So if it navigates from one place to another, it can also calculate the costs related to all of these decisions. So if I choose a certain route, how much time does it take, how much fuel is needed, and other kinds of metrics can be estimated to maximize the utility. And the utility can, for example, in this case, be some kind of combination of it tries to minimize the fuel consumption and minimize the time needed to reach the target. And it could be some kind of combination of these. And then it can try different possibilities to reach the route that has maximum utility or minimum losses. Sorry, but are any questions or comments? So this is more like, then we can start discussing about optimization. So to optimize the behavior of an agent. And now we can already implement really complex agents. And when I say that in this navigation case, this agent can kind of try different options and find the optimum. It's like, it would be like kind of brute force search method, and that is not that clever yet, but probably it would need some, it would use some more clever algorithms. We will discuss about A-star algorithm later, or Dijkstra's algorithm, and they are more clever search algorithms for graph, for searching part in a graph. That's we can modify or actually describe this problem as a graph search algorithms, and there are quite clever algorithms for that purpose. So the intelligent agent would utilize some of these clever algorithms and find an optimal path. And then even more interesting would be a learning agent. Let's skip to this directly into this picture. So in addition to be able to observe the world and model the world, this can also, the algorithms which is contained are not a kind of pre-programmed, but this can learn to perform better all the time. So it would start, for example, in some the auto navigation in some city, and then it would like maybe start without any kinds of map. It is just kind of trial and error trying to search its places, and then it gradually learns the map of the city, and then it can perform better all the time. But this is like now consisting of the same structure than previously. That is the performance element, that is the agent, that is getting these perceptions and making actions based on these perceptions and other information. And it has also a learning element that is changing its algorithm or its models according to its observations. And it must have also a critic element. So when it receives these perceptions and it makes some actions and for example drives in towards certain goal, it has also a performance standard which measures that how well it did perform, and it gives feedback to the critic element, which can then instruct the give feedback again to this learning element, which can then try to find out better models or better algorithms for solving this same problem better way in the next time. For example, if this car selected a certain route from location A to B, and then the critical element said that this took very long time and also took a lot of fuel, then this learning element knows that, okay, we have to, this was not a good choice. So, and last time we made this choice based on this kind of assumptions, so some of them are not true, so we need to adapt the algorithm a little bit. And if you imagine that this is a self-driving car in a city with no map in the beginning, or very simple map in the beginning, then it would always kind of, so how can it learn a new routes in the city? Because it only knows a few, and it doesn't know where the others belong to. So if you take an unknown road, how can you argue that this is probably more optimal than the other route that I already know? It's not possible. So there is a danger that this agent would always go to same routes and wouldn't learn the other possible routes at all. So therefore, also this learning agent has a problem generator, so that it can also sometimes suggest this agent taking a new route just to try it. That, okay, I cannot tell that if this is the optimal thing, but we need to try this so that we learn more about this, the map of this city. So it tries to have a balance between optimizing based on the information it already knows, but also sometimes taking a risk, taking a new, trying new solutions. And it may be that it finds out eventually that this was a bad choice, but then you have at least learned something. Or it can find that, okay, this was a very good route, we will use this also in the future. So this is obviously much more trickier to implement than this previous one. And this is, and there are of course, many ways how to do it, but basically you will need these kind of sections in it. It may depend on the algorithm that how visible they are, how separate they are, maybe they are all combined, but you need these kind of logical things into this kind of intelligent agent. It has to be a learning element, and learning element must get feedback that did you perform good or bad. And it needs to have some means of also exploring a new world, taking risks, trying different kind of new opportunities. And even though now it looks like that this is something like concrete agent that is steering a car or doing something like physical thing, it can be also something purely in a virtual world, for example, reading stock markets and making decisions about investments and so on. So it does not need to have kind of physical actuators or physical sensors. They can be also purely virtual. So this model should fit to almost all kinds of purposes. Yes. Only one point remaining. So what if this kind of agent, again, yeah, this reflex agents, it kind of assumes that it can measure all the things necessary. It can observe things, and then I try to stop this recording, but this menu doesn't work. I had to stop sharing for a while.